And we're back. We're back, and it's COMP392, and it is week 6, part 1 of our broadcast. And so we're not doing this a midterm test this week. It's going to happen, of course, next week for those people who are slightly off the outline in terms of our timing. But think about it, next week it'll be done on the Wednesday, right? The Wednesday, that's the time frame we're going to do a midterm test, and it's going to be purely practical. So I'd like to start with that, right? So advanced graphics here at Centennial, right? So when I say practical, what are you going to do? What am I going to test you on? What would I test you on for next week? What have I asked you to do so far? Rotation, some movements, you know, putting some stuff together. Am I going to ask you to make an avatar bounce a ball? Probably not. No, that's not going to happen, right? Am I going to get you to build something with some basic primitive blocks? Probably, right? So am I going to make you construct something, an object out of primitives? Put some lighting into the scene? Probably. You know, move the camera in a specific position? Most likely. Those kind of things are going to do. Am I going to ask you for textures? No. It's not. I haven't really talked about textures, right? So I can't ask you for something I haven't talked about. However, what I might do is we're going to talk about for today, this session, and next day, because I want to prepare you for the next assignment, which is assignment 3. I'm going to talk about things like, I know she's like, oh my God, not another one. I'm going to be talking about how to move the camera around, right? Because one of the things I asked you to do for assignment 2 was, you know, zoom into that camera, move the camera to a specific spot, right? There's ways of doing it. Switching cameras, you can do it that way. You can also do it so that you move the camera into a specific location. But what I want to start doing today is I want to talk about a couple things. One is I have a library. 3JS is a big JavaScript, is a selection of JavaScript libraries and examples, right? How do I access a library? I want to use TypeScript, but how do I access a library where TypeScript doesn't exist? There is no type definition library at all, right? And I want to get code hinting, right? How do I do that? So if I was going to access, you know, a library that's there, how do I build one? And I've got a gist that I put up on GitHub. We'll take a look at, and so we can look and see how we can do that. I've kind of put together a declaration for one of the libraries that already exist. And I want you to take my type definition. I just created a type definition library and include that into your code. So we'll do that a little bit today. And then with that, I want to create a camera movement where we actually use first-person camera movement to zoom into a scene and move around the scene, okay? That's what we're going to do today. Very, very simple. Next day, so this is today. Next day, I want to build a maze, right? Just like we've done in Unity for people who are with me in Unity. And I want to use the camera to navigate the maze. Just go through the maze with the camera, right? I'm getting you ready for first-person shooter, right? I can't give you first-person shooter assignment without giving you all the things you need to create a first-person shooter in with 3JS. It's very complex, and we'll probably spend a few weeks on it, 3 or 4 weeks, just talking first-person shooter. I'm going to give you a little bit longer on this assignment, the one I'm going to give you, assignment number 3, because it takes longer, and there's a lot of little piece parts. Also, I'm going to start using other libraries to help us to generate a game like heads-up display. Like, for example, I want to get some sounds going, right? I'm going to introduce you guys to Sound.js, which is part of the Create.js library. For those people who did COMP397 with me, or who are doing it today, and there's, you know, one super girl that's doing that today. I think there's a couple people. Who else is doing COMP397 with me today? I know I got that's web game programming. I got a couple people that are doing that's on the Fridays, right? Well, the stuff that you guys use, there's Easel.js, which is for COMP397, which we do for Canvas, but we're not going to do a Canvas renderer here. We're doing, you know, we're using WebGL. So I can't use the Easel.js piece of Create.js, but I can use the other pieces. I can use Preload.js, I can use Tween.js, and I can use Sound.js. And those things allow us to create the game elements we want. And we can also use a canvas, right, if you want to render things like the score. Because remember, it really, at the end of the day, our web page is a web page. So far, we haven't treated it like a web page. We've been treating it like the whole thing is, you know, one big page. But you can add a score. You can do all those kind of things that you normally would add on a web page. You can do that with this, right? So we'll be doing that. We'll be talking about that over the next few weeks, how to create score for your game, how to do collisions, and how to incorporate physics, all that kind of stuff we're going to be doing. So this is the next harder section. So the first piece is you were introduced to, like, hey, here's some basics of 3JS. Here's some basic primitives. Here's how to move things around. You know, and then the next piece is going to be, okay, now that you know how to move things around, how do I do physics, basic physics? And we're going to use Physi.js, which is a physics engine that's based off of Ammo.js, which is actually a port of bullet physics. So people who are familiar with bullet physics from game engines like Unreal and like Unity, then you'll be very familiar with bullet physics that we're going to be talking about over the next course of weeks. We're talking about several weeks, right? So next week we'll do, we're not going to teach and we're not going to do any teaching next week. All right. All I'm going to do next week is review on day 1. So this day, next week on the Monday, it's pure review. Well, I'm going to go over some basic concepts and things that you're going to be tested on. I'll give you an example of what my exam is going to look like. So you're not going to be, you know, surprised of what you're going to get. It's going to be purely practical next week, right? That's what's happening on Monday next week. And then on the Wednesday, we'll be doing the exam, and you'll be getting a framework. I'll ask you to probably download something from GitHub. Say, take these files from GitHub, make them your own, create your own GitHub repository, throw them up on Azure. Like, these are all the things we've been doing, and so that's what you're going to be tested on, right? And then, you know, put together these things, create this shape, make these movements, add this GUI control, all the stuff that we've been talking about so far. Open book, absolutely open book. Because for an exam, either you know it or you don't, right? I can't, it's not like, you know, you do your little quizzes. That's more like understanding what to do, some terminology. But for the exam, it's all open book, and I want to give you the opportunity to, you know, to do your best, right? So, and there's also going to be some bonuses. Remember, I always treat my exams like a little game jam. So whoever finishes first, I'm going to give 5% bonus to, which means, you know, excluding Steven, I don't know. Maybe I'll give the first 3 people 5% bonus. How about that? To give a chance to, so someone can compete with Steven and other people who are super good, right? Those kind of things. I want to be able to give you some bonuses so that people who didn't do so well on their little quizzes can make it up with the exam and the assignments and stuff. I don't want to make the exam too hard. I want to make it a little bit fun, right? But I want you to be able to do it quick. So when I ask you stuff to do it, it's like bang, bang, bang. You know, you get it done because I want you to be that good at it. People are laughing at me, going, "What? He's crazy," right? I'm crazy, right? That's how I am. Okay, so any questions about the exam next week? You know, or I can't call it an exam, midterm test, right? Because it's not really big. It's like 10%, right? That kind of thing. It's not going to be anything you haven't seen before, and the format is going to be exactly like, it's like an in-house or an in-class assignment. That's all I'm treating it like. Think about it, it's due by the end of class. The only thing you can't do next week is you can't talk to anybody, and there's no cell phone use. So you can't do things like, you know, text each other the answers or do any kind of social media or anything like that. That's going to be off the table. So cell phones, I'll be asking you to turn off your cell phones, that kind of thing, or turn them on to airplane mode or whatever. And then, and that's about it. Okay, let's get to it. So where last we left off, if I was going to look on GitHub, let's go on to GitHub for here together, my friends. And I'm going to go look at Centennial, right? Centennial here for GitHub. And I've got lesson 5, right? So here's lesson 5 up here from last week. There it is, lesson 5. And notice that in lesson 5, I have a bit of a gulp file.js and everything else. I want to base lesson 6 off lesson 5, might as well, right? Since we're going to be talking about it, I want to start from scratch. Hey, hint, hint, this is what you're going to do for your exam, right, next week. Let's just download this thing. So I don't have a lesson 5, but if I was going to do it, I would download my zip file, and then I'd start from there. But let's do it from I have my own files locally, so I don't have to do my download. I'm just going to take lesson 5 here and duplicate it. There we go. And then I'll just rename it to lesson 6, because this is what we're doing today. So if you want to follow along, you can wait for a second, and I can put up lesson 6, and you can download that, or you can download my lesson 5. It's up to you, whatever you want to do. Okay, so let's talk about lesson 6. Remember what I do, and this is what you're going to probably have to do if you're going to download something of your own, right? I'm going to bring up Visual Studio Code here, and I'm going to drag and drop lesson 6 in here. There we go. Right here's lesson 6. And I've already got a Git repository which I want to blow away. So I'm going to right-click here and open in terminal. And let's try that again. And when I open it in terminal, here I am in lesson 6. I want to just do an rm -rf.git. And you can also go on the Windows side. You don't go in there and remove the hidden .git folder. So you can blow that away and start from scratch. I'm going to do a git init, which is going to initialize my repository. By the way, for next week, I don't care how it gets on Git. I don't care if you use command line. I don't care if you use your tools. I don't care if you use Visual Studio 2013. It doesn't matter how it happens. I don't care what tools you're using. I'm introducing tools to you, but at the end of the day, you're the developer. I'm not going to be testing you on, are you using Visual Studio Code? Are you using Cloud9? What are you using? I don't care. It's up to you at the end of the day. So git init, and I'm going to say git add dot to add everything to the staging area, and then git commit -m, and I'm going to call that initial commit. Now there's some changes that I got to make for this one because it says less than 5, which I've got to change and make less than 6. So up here on my README file, I'll make this less than 6 for advanced graphics. And you've seen this a bunch of times, guys. So there's no surprises here what I'm doing or changes. And if I was going to base my new stuff off of what I've been doing before, I mean, it's pretty straightforward. Nothing that you haven't seen. Well, my index.html, less than 6 here. There we go, and let's go to my Bower and change that too. Why not? All these things, different places. Notice that I've got a bunch of places where I've changed. I've changed stuff. I've got like 4 files that I've updated, and I'm going to save all. And now I'm going to go into GitHub here in the tool, and I'm going to go upload to everything to the staging area on the modified, and say in my commits I'm going to say updated. Files to reflect less than 6. There we go. And I can't push anything anywhere. Why? Because I don't have a connection yet. So I'm going to go and create one here up on GitHub. I'm going to grab this name here so I can do it quickly and go and create a new repository. Definitely in my Centennial College area there, and call it less than 6. There we go. Grab these last 2 lines, and then go to my terminal and implant them. There we go. Boom, boom, boom. If you want to grab it now, I've got less than 6 up on GitHub, right? Nice and quick. Hey, if I was going to do the exam, what would the next step be? What would you think the next step should be right now if I was going to do the exam? Was that? Cloud deployment right away. Why? You're going to get points right away. It's going to, your part of your exam is going to be GitHub and cloud deployment, which is going to be worth 4 and 4 marks, right? Might as well get it all done. That means you're going to get your at least 2 marks for GitHub, because I just by doing this, it's 2 marks for GitHub. And I put it up on the cloud, that's another 4 marks. It's 6 marks, right away, without doing anything. Let's just get that done. So I'm going to go to portal.azure.com, and I got several up here. I'm going to add another one in here. I'm going to go to plus. And I'm going to go to web and mobile, and I'm going to throw it up here on the web app. And it says sign up. How come it says sign up here? If you guys get a sign up, what does it mean? Anybody? I'm logged in as Georgian. That's not what I want, right? I can't log in as Georgian. It remembers that I'm logged in as my Office 365 Georgian account, right? Or if I was Centennial, it would be Centennial. You can't log in with it with your local account. That's why it's asking me to sign up, because it doesn't recognize me. So what's the easy way to do it? I'm going to take this, go into incognito window, right, and do that again. Let's try that again, right? Now it doesn't know who I am, right? And I can type in my credentials as I want, right? I got to wait a second because it's going to redirect me back to where it's supposed to be. And luckily, it's not going to remember who I am. Put in my password, and I'm doing 2-step authentication. My authenticator is here on my phone, and I'm going to go in there. And by the way, again, I do recommend 2-step authentication for security, especially if you're using any kind of Hotmail, Gmail, whatever. It's a good way of doing things. Submit. Notice I did not click I'm using this computer because it won't remember me anyway, right? Because here I am. Okay, cool. So I'm here, and I want to add a new web app like I did before. Web app to mobile, web app. And now let's call this, you probably took it already, so I'm just going to make it my own. So I'm going to say COMP392 winter 2016 semester, and it's lesson 6. There we go. And if it's not taken, we're good. I'm going to click create. Oh, one thing to notice is the default resource group here. I'm going to mention this for a second. Notice that it tells me my default resource group, my storage east, storage west, default web east, US and so on. And I can create another resource group if I want to later on, if I don't want to use this. But I'm going to use my default resource group. Notice that it says East Asia, right? That's my default resource group, right? Or I can choose East US. By the way, none of these, it doesn't have to be whatever you want. You can choose whichever resource you like. I'm going to just choose this one. I'm going to create CREAS. So this is East US now, not East Asia anymore. It's important because if you ever use something like, if you're a person out there who's been watching my videos on COMP392, notice that I couldn't connect to MongoLab with, as an example, through Azure, you need to have the same resource group in the same location. You have to specify that on the MongoLab side. Okay, for those people who are watching COMP392, you'll know what I'm talking about. All right, I'm waiting for this to come up. And then when it does, I'm just creating a location for this to come up, right? A container for my web app. And here I am. And now I'm going to go down to continuous deployment, which is under publishing. And I'm going to choose my GitHub. I'm going to go into Centennial. And then from there, I'm going to choose my project, which is COMP392 lesson 6. And then click OK. And if everything goes well, and if I haven't made a mistake, it's going to deploy to Azure. Now I'm going to wait because this is the problem. Sometimes you rush, things don't work like you think they should, and you think it's going to work, but it doesn't. And I always wait for my deployments to finish just in case there's an error. Then I can address the error. Otherwise, I'm going to come back to this step and I'm going to repeat my work. I don't want to do that. Now, for next week, my assumption is that you have access to Azure. So if you do not have access to Azure for your exam, you got to fix that. Okay, baby? If you don't fix it, I can't fix it. I will not fix GitHub problems or Azure problems next week during your exam. So you need to have all that ready to go, right? Now, I'm going to also allow you to use Cloud9, or if you don't have a laptop and you don't want to use the machine in front of you, I'm totally cool with you using a machine that you team viewer into. Okay, so if you want a team viewer into your server at home, I'm totally cool with that. That's all right with me. Okay, so here's my files as an example, and it looks like it's a checkbox, which means I can probably go over here and then test out my app, right? Let's see what I got. Let's see what COMP392 lesson 6 looks like. Whoa, this is what we were talking about last week, right? So this is kind of an interesting little thing. You have some rotation speed over here and whatever. And you know what? I want to use this example here. I'm going to take some of these cubes away and change the background and whatever, and maybe make this a little larger. We'll see how it goes. Maybe 800 by 600. We'll talk about this in a second. Okay, cool. So that's what we were doing last week. Okay. So it's working. It's up on Azure. Cool. So I just got 6 marks by doing that, and that took me the better part about 10 minutes. So about 10 minutes, you get your marks for continuous deployment in your GitHub. And now I can work with GitHub, and I can get my other 2 marks from GitHub, and I'm probably going to make you do a minimum number of commits based on your tasks. So let's say I'll make you do something like 5 commits or something, whatever, how many tasks you have. I'll say, you know, if you do 5 commits, you get another 2 marks or whatever it's going to be. All right. But I can do that now because I've got a space for my, I got a container that's running. It's my deployment's already there, and I've already got a place on GitHub that I can start running with. So I'm good to go. Notice that I already have 2 commits, my initial commit, and plus I updated my files to reflect everything. And again, there might be other things I might ask you to do. Okay, cool. So now that's number 1. 2, locally, I've already installed, in this particular example, Gulp, right? Gulp-file.js is here. So if we did all kinds of stuff with Gulp last week. I'm not going to get rid of that. We're going to use Gulp from now on because it makes sense from a transpilation perspective. If you're someone who's using things for, and I did some examples online on YouTube, if you're doing the mean stack, Gulp also works great for the mean stack, and you can always do things like restart your server, NodeMon, if you're using NodeMon or something else. From a development perspective, you can use Gulp, which is really cool. Okay, and you did a lab to that result. Okay, so I'm going to launch Gulp then, right? I'm going to try this out. So I'm going to just say Gulp locally here, and it should launch my window. Here I am, and this is what's running locally. Now all I have to do, every time I make a change, it'll appear here. I don't have to reload my windows or anything like that. Okay, cool. Let's get back. So I can kind of minimize this window now. Yay, all right. I'm not going to touch the Gulp, this Gulp configuration. It works pretty good. I could probably cut it down a little bit. I don't need it to be so thick, but it's okay for now. All right, let's go back into my scripts. And I want to talk about what I'm saying. So let's go back into my core, into my game.ts. And I got all these files. And one of you guys might say things like, Tom, do I really need all these files at the top of my code here? And the answer is, you don't need to do this way. And I would accept it on the exam if you said, hey, you know what? I don't want to do this alias stuff because it takes up a bunch of lines. I'm creating almost like other names for my 3.js library. And I just want to use the 3.js library the way it is. Hey, that's cool. Go ahead. Do what you want to do. I like this way because it simplifies my life when it comes to coding. You do it how you like it, right? Let's talk about a couple of other things, though. Notice that I've got my imports here, but one thing we haven't really practiced on is the IFI. Remember what the IFI is, right? Right? It's a immediately invoked function expression, right? Which we talked about, right? So how do I implement an IFI around this code? And for those people who remember JavaScript, I haven't done that here. Notice that there is no IFI. This is all in the global namespace, right? So one thing I want to do today, which can be a little different, is I want to kind of use the IFI structure, right? Let's try that out. Again, this is the advanced stuff we're going to be doing, right? So I don't want to touch this, anything under the imports, and I'll tell you why. If you include your IFI around the imports, it'll fail. You want your imports to be outside of the IFI structure. So let's do this. Let's go. Again, let's call this thing game. So I'm going to go var, follow me here, game is equal to, here's my IFI structure, function, right? And this is the funny thing we're going to do here, right? And then what I'm going to do is do one of these, and that's a self-executing anonymous function, right? So in here, in this area here, I want to put all this stuff I've just got in here. So what I'm going to do is I'm going to highlight all this all the way to the bottom. And then on the Mac, I'm going to use Option and up arrow, or on the PC, it's Alt up arrow to move this up into that structure. So what I want to do is I want to move this without cutting and pasting it into there. And that's what I've done right now. Notice it's at the bottom, so I don't have to do that cut and paste. There it is, right? And I've got my IFI structure so that my var game, and you're going to say, well, how come I did var game is equal to this? Why don't I just do the IFI structure like this? Ah, there's a reason, right? Once I do this, once I name the IFI, it's like this whole thing is an object, right? Which means I can refer to this object for debugging purposes on the browser, right? Which is kind of a cool thing to do. Notice also that my game returns void right now. Well, I don't want it to return void. I want my IFI structure to return my init function. Why would I want that? Let's try this out here. So I'm going to go down here as an example, and down near the bottom of my IFI structure, this is something new that you may have not seen. I'm going to do a return, right? I'm going to go return, because this is a function, right? And I'm going to return an object. Here's the object. I'm going to say, I'm going to return init, which is going to be just init. Do this. Get this out. And I'm going to reformat my code so that it's all lined up properly, right? That's all I've done. And I'll show you that in a second again. And I'll take away some spaces. There we go. And now that I save, right, notice that my gulp will redo everything, so it'll restart my server, so that's all done automatically. And if I go back to my page, does it work? No, sir, it doesn't. How come? Because we also have a couple things that we're doing on my index.html page. Let's take a look at that. So if I go back to my page here, and I go back to index.html, what am I doing on the onload function? This is an ugly structure, and I want to get rid of it. I don't want to ever use onload methodology here on the body tag, right? So the body tag shouldn't have an attribute that's onload. That's kind of an old school way of doing it. I want to self-execute. I want to say this, window.onload is equal to init. That's what I want to do. So this is going to go away, right? And inside my script structure, right, I'm going to go back to my script for a second. And near the bottom, just before my return statement, right here, in the global namespace of my function, it was inside my IFI, so it's not really global. I want to do window.onload equal to init, right? That's what I want to do. So basically, what this is doing is saying, hey, my onload, my callback function for the onload event handler, or the event that's happening when Windows loads, I want you to access my init function. So that's what's going to happen. As soon as the window loads, my init function is going to be called, right? So this happens inside my IFI, which self-executes. With self-execute, it just makes everything go, right? All right, let's go back to show you that this works. I'm going to go back here, and there we go, right? It's running already, right? So I've done a couple things here. I've encapsulated my code inside of an IFI, and that means that I can have multiple scenes now that use the exact same variables, and they're not going to clash, right? They're not going to clash because they're inside this containing structure, this self-executing anonymous function. Okay, cool. That's one thing. That's the reason why I did that. Questions? And also that when I went fast there, right? So people were like, "What the hell is he doing?" Okay, so I went to the top, and this structure here is really the iffy. So kind of set up an iffy structure, which is really immediately invoked function expression. That's what it stands for, right? There it is. And what this does is encapsulate all of our variables, all these variables, these vars that were normally in the global namespace. Now they're inside this iffy. Okay, cool. And I've also named it. I called it game, right? Well, that means that I can refer to this thing, right? This game object. And notice that if I hover over it, TypeScript knows what it is, right? It says this. It says, I'm going to return, right? My object I'm returning is a function that returns void. Notice that? It's doing it by type inference. That's what this is doing, right? And if I want to really be specific, right, notice how this structure here says function, right? If I want to use the TypeScript way, I want to get rid of it, or this is also ES6, right? And I'm going to use the fat arrow function like we've done before and point to this. Right? That's the proper way of doing it. I'll save that, which will immediately execute everything, and back to this, right? It's still working, no problem, there it is. So all I've done is, this is the fat arrow function. This is equivalent to function, you know, that kind of stuff, the way we had written it before. And if I look at the JavaScript code, just to give you a sense of what it looks like this, right? So I've got my reference. As I go down in here, here's my iffy, and it's back to what you normally would see, right? Nothing different here. Okay, let's go back. So I can do this. This is the TypeScript way of doing an iffy. Okay, cool. All right, so now that I've done this, and I do this at the bottom here, I return this init function. I can return whatever I want down here, right? I'm returning init so I can access it. Let's show you what I'm talking about. If I go back to this, and if I go and look at if I do an inspect, right, as an example, and I pull this up, and if I go to console, and if I type in game, and I press enter, right, I get an object. Look right here. If I press in game, look. I press game, enter, and I got an object. From a troubleshooting perspective now, I can inspect this object right here in my browser, right? So I can open this up. Oh, look, it looks like it's a init function. Oh, let's take a look what's inside the init function. It's a prototype, as an example. And I can return anything I want. I'm just returning the init function right now. I'm going to do a couple of other things, right? Let's take a look. Right, so here's my function init, and then you can see that the whole function structure is there. Okay, that's cool. I like that. What about what's inside my function? I don't want just to see my object, which has a init, right? I don't want that. I also want to see some stuff inside. Like my scene would be really cool to see. If I can see my scene, that'd be awesome, because then I can inspect all of my elements in my scene, right? Which is going to be, you know, kind of cool to see. So let's do that. If I was to go back out to my iffy for a second, right, and I want to be able to see my scene, can I see my scene here in this place next to the window on load event? Can I access my scene here? The answer is yeah, I could. I could access my scene here, right? My trouble is that if I access my scene here without the window on load init method working, right, without this happening, right, if I haven't got to my init method first, my scene, what's my scene's value here in this namespace? If I look at my var scene, do I define what scene is? No. So right now it's undefined. I'll show you that. So if I go down here, right, into my return statement for my entire file is returning something, right? Right now all I'm returning is init. Let's change this. So instead of init, I want to return scene. There's my scene, right? And I'm going to press save. When I do that, this is immediately changed. If I go back to game and press enter, I notice that I have scene and it's undefined. It's undefined. Here's my scene that's undefined. It's undefined because, man, oh man, right? We're not accessing it at all. We're not defining it at all in this particular space, right? The reason why is because remember that JavaScript fires, it sometimes does things asynchronously. You don't know when it's going to call the init function, right? And you don't know, it's going to try and resolve all my variables, right, at the top. It's called hoisting. So I'm going to take my variables and I'm going to hoist them to the top of the file, right? Because that's what JavaScript does before it gets interpreted, right? So that means if I ask you for something down here, what I'm actually saying is, hey, define a variable called scene and make it, you know, the value of scene is going to be called scene. Well, I've defined them up here, right? But I don't have a value for scene from init. The only place that scene gets a value or becomes an object is inside the init function, right? So I could very well return, right now init returns void. If I kind of hover over it, it says, you know, TypeScript by type inference, it says init returns nothing. I could return an object from init. I could say something like, you know, the scene that comes from init, but I don't have anything coming from init. How do I do that? Well, down in init, I could say, first of all, init's going to return an object of type scene, right? So that's how I do that by doing one of these. Now, it's an error because there is no return for init yet, but I can go back down to the bottom of the init function, right? Just before I go window.add event list and a resize, which, by the way, I'll take away for this one, right? And I can do the same thing. I can say return, right? I can return an object, right, of type scene. Go, right? Now it says, hey, I don't know what scene is, right? It's not accessible. Could I not, though, do this? I could return a whole scene object itself, right? I could do this. I could do this, right? Returning scene, which is of type scene, that satisfies these requirements. What's the difference between me doing this, a single variable, or this, in my return in JavaScript, returning an object? What's the difference in terms of what I get, right? One's an object and one's a variable. Let's take a look. So if I say scene, I could do something like this. Init dot, do I have access to scene? The scene doesn't come up with that, right? It's because I'm returning just the a variable, right? I can't do this, even if I wanted to. I could do this. If I just say init, what am I really doing here? Nothing, right? If I do this, that means I'm calling scene, I'm getting a return, right? Okay, that's not what I really want, though. I want to be able to return scene, the scene that comes out of my init after it's called, right? That's what I'm really looking for. And that's where when I go back up here, right, notice how I said I'm going to return an object of scene. I can't do that. Let's just get rid of this for a second. At the bottom in my return, what I really want to do is that thing that I did earlier, which is one of these, which is an object, right? And I want to return scene. If I do this, that's okay now, right? Because it's looking for this kind of return. And type inference in TypeScript, if I go up here, as an example, and hover over my init, it looks like I'm returning an object of type scene. That's okay. Now let's see what I can get when I come down here to over here to this piece. So if I do this scene that I'm returning out of my iffy, right? Can I do init dot scene? Still no, right? Because scene is not a property. It's not a property of the init function. How do I make scene a property of the init function? Is there a way of doing that? Who remembers JavaScript 101? How do I return an option, a property of type scene? If I was to do this, look, if I do this, init like this, right? If I do that, do I need this window on load calls init? If I do this again, it calls init again, right? When I return an object of type init, I'm calling it one more time. So I can't do this because this calls the brackets. Remember these two brackets call the object. If I just do this, I refer to the object, right? So let's see what I get when I just do this. If I do scene init, what am I really getting here? If I go back out to here, and if I go to game and press enter, I still get an object. And if I open it up, right, I get an object, which is the function init. Inside my scene, even though it's called scene, it's not really a scene. And if I go in there, here's my prototype. And this is prototypical inheritance here. If I go into my prototype, I still don't see that I have access, you know, to my scene object, even if I bury myself in here. Although I'm starting to see stuff like my game loop, Here's my plane. Take a look. I have access to my objects in here in my scene. Here's my array, which is so I can see my plane. My plane has no children right now. But my cube, my object, my game object, which I've already got in here, this is a game object with another object that's circling it. I should be able to go in there and see that. If I go in and to see my game object, it's called game object, right? So let's take a look. Where is that? There's eye control, ambient light, axis, camera. Here's my child cube. I see that. Here's my control, right? My cube, which is a type game object. There it is. And inside my game object, I can see that. Do I have any kind of children? Yes, I have a one child, which is my empty game object. Here's my empty game object, which also has a child, right? Which is my if I look through here, if I keep going down into the dust of things, so I can see that I got another cube that's the child of these things. So it's good for troubleshooting to be able to do that, but I still haven't got what I wanted. I still haven't got to do a kind of a game kind of thing and get something that I'm looking for. Anyone have any suggestions? How can I do that? How can I get access to my scene? There's an easy way to do it. I can just say scene, right on declaration var scene is equal to new scene. I could do that, and that would give me the what I want, right? But I want my scene to be initialized inside my init function, right? And then I want to get the value of scene, right? No one's giving me any answers. Well, let me go back to my code for a second for you to understand. This is important from a scope perspective. So go back to this. If I do scene, right, even though I return it back out, when I call my method here, I'm calling my method on onload. So this actually is taking the scene object, and the Windows objects knows about scene. So if I kind of save that and go back down to here and press game, now I got the scene is undefined. Notice? Scene is undefined because the scene that it's referring to, right? The scene that it's referring to is the scene that's up here in the variable declaration, which has nothing. It's just a reference to the scene class. That's all it is. And it hasn't been assigned yet. The only time it gets assigned is when I'm doing this. But when I go down here and do a return down here, what I'm actually doing when I do this return in my init function is it's taking the completed scene object and returning it back to the calling function, right? But what's the calling function for my init function? The window.onload method, right? Here's my window.onload method down here, right? Window.onload calls the function. As soon as onload happens, the init function calls, it's being called as the handler for the event listener. Here's the event listener, onload, and here's the handler function or the callback, init, right? So that's why this is undefined. And undefined because of what it's doing. So quick and dirty way to do it is, let's get rid of this. So you understand, from a scope perspective, people are calling me up or sending me some mail saying, I don't understand why my object's undefined. Well, because it depends on how you declare it, right? If I was to do one of these up here in my scene, if I was to do something like this, equals to new scene, right? I can do that up here in my variable declaration. Not good form, but I could do this. Now I can't do it twice, because this is just redefining it twice. If I just do kind of opt out of that one, press save, and go back, it still runs, right? And now if I press game and press enter, my scene is actually a 3JS scene, 3 scene, right? And if I open it up now, I get a scene that has a 3 scene, and I get a really nifty little array of children. I get 5 children. I can see, I don't know if you guys can see this, 3.axis helper. My second one, this is in the display list. This is really useful information to give you an idea of what's in here. A game object. My game object has my plane geometry and so on. Make sense? So that's why you can see it here. To do some troubleshooting, and this is important because if you're getting undefined, there's a reason why it's happening, right? So you know what your scene is made up of. That's what this scene is made up of. These 5 objects: my axis helper, a couple of game objects that I've got in here, right, and my ambient light, my spotlight, and then one of these game objects has a game object that's inside of it. A couple more things before we move on to more important stuff, right? This is just a little bit of review. Okay, so I got this. But any object that's of type object 3D, which is the superclass of all objects in 3JS, right? Object 3D is the superclass, right? it has a name property. I can assign a name property to it. It's built into Object 3D. So if I do that, I could say something like this. My plane, right, this plane here, before I add it to my scene, I can kind of give it a name. I can say plane.name, which is part of the Object 3D library or class, is equal to, we'll call it ground, right? That's the ground plane. Okay, there we go. So I've given it a name. And I'll do the same thing for my cube object. My main cube object, the one that's the big one, but the small one is kind of you know, rotating around. I'll give it a name too. I'll say, you know, cube dot name is equal to like big cube. Is my big cube, right? By the way, you can make it's a string, right? So you can give it spaces and everything. And then I can do the same thing for my empty object. I'll make it so that it has a name too. I'll say, you know, empty object dot name is equal to empty. I can also call it spawn point, node, rotation point, whatever I want to say it. What I want to call it. My child cube, I'll just call it child cube. So child cube dot name is equal to child cube. I want to give names to things like this because it's great for troubleshooting again. Because I can see what object they are, right? Go back, save, and launched, and then I can do something like this, game, enter, and I see my 3JS scene. And inside my scene, I have my 3 scene, and I have my objects. Here's my children of an array of 5. And now I have my game object, but my game object has some name, right? If I go through my game object, is my plane. Cast shadows is equal to true. And notice that down here it says my name is ground. This is important when it comes to, I'm showing you this because if we ever try and do something more complex, right? You want to be able to identify which one of them is what. Hey, here's a disadvantage though, eh? I've kind of created my own class called game object. They all look the same, right? If I go back here, notice that in my array, I have a 3JS axis helper, a couple of game objects, an ambient light, and a spotlight, right? And notice that game objects, you can't tell one from the other here in the troubleshooting until I scroll down and go, well, that's a plane. And this one, well, that's a box, right? There's my box geometry. Okay, let's take a look at my box. My box is this is the big cube, and it also has an array of children, right? Here we are, we have an array of children, right? And I have one child object, right? And what is it? It's a object 3D, right? There it is. And it has an array of children down here. And now if I look through it, you know, it's the small cube, but this is empty. This is the empty cube. And if I look at the object that's inside, I see that it's the small cube. Child cube. Right here. So you can actually look through the entire hierarchy of your game this way, and I think it's super useful. One other thing that all Object 3Ds, if you look at every object that's derived from the Object 3D has, it's given a unique UUID, right, by 3JS upon creation. Take a look. This UUID identifier, which is important to note, is different than this one down here, right? Each one of them is a unique ID. And why do you think that we do this? Why do I have unique IDs that are automatically generated by 3JS? Why would I need that? For collisions, for location, for later on. They've actually planned ahead, knowing that I one day will have to know that this object is different from the other objects. And that's yet another way of defining what the object is. Even if you have two cubes, they're totally different cubes. They're different instances of the cube mesh object that we've created, right? Okay, just a note. So UUID and name are two properties that exist in all Object 3D objects that are part of, that's a superclass for all other objects that are on our screen. Okay, a little bit about troubleshooting. I want to get rid of my little rotating cube now. I don't care about that. I want to change this cube into a sphere. Let's do that together, ladies and gentlemen. Let's change the cube into a sphere, right? I want to make my sphere a different color. Let's make it reddish, right? I want to make my ground brown, a brownish kind of ground, right? And I also want to add, I want you to try and do this with me. I want you to add an axis helper to the cube, to the sphere that I'm going to replace the cube with. So we've got an axis helper. Notice that the axis helper is staying in place, right? For the scene. The axis helper is attached to the scene. I want you to attach an axis helper to the sphere, all right? So the sphere has an axis helper as a child object. Okay? Don't attach it to the scene this time around. And let's see what the effect is. Keep the same controls, so the rotation speed is going to be the same. I just don't need a child object or an empty object that rotates around anymore. Just the rotating sphere. Okay? It's hard to see the sphere rotating because the sphere is a sphere, so it looks pretty round, right? So you won't see much movement in terms of where the sphere is. Let's do this together so you understand what I'm talking about. All right, let's go in here. I don't want to make it a cube anymore. So I don't. This axis helper is cool, but I want to add this axis helper to the sphere, not to the scene, right? So let's get rid of this cube and the empty object and the child cube. Get rid of all this stuff and just get rid of it. And we'll start from scratch, and you help me out to build it. For those people who don't know, this is great practice. A lot of change we have to make this thing go, by the way. All right, so I got my renderer set up, which is WebGL renderer. I got my camera set up, which is its own little function. I'm gonna put my axis helper on the scene, but it's not gonna be on the scene.add. It's gonna be sphere.add. For me to be prepared, I need a couple of variables that I want to have up here to hold everything. I don't need a cube geometry or a cube material. Let's get rid of those just to make up, save some space, and a cube mesh and an empty object. These last four from lines 50 to 53. Let's get rid of all that. Don't need all that. I'm going to keep my spotlight in place and my control and all that stuff. And notice that I have a cube and a plane mesh. I don't need those. I'm going to clean up today. So we haven't been cleaning up too well. Let's clean those up. There we go. And I'm going to add in a sphere. I've got my sphere mesh. I need my sphere material, and I need my sphere geometry. Those two things I need. Let's add them in. So var sphere geometry, right, is of type sphere geometry, right? Remember, I've got those shortcuts in place from up here, right? Sphere geometry. I did a bunch of them. If they're not there, you can always add them in, right? Var sphere material, right, is sphere material. And notice what kind of material is going to be. I want to make it Lambert. Right, so I want to make it type Lambert material or 3 Lambert material. Match Lambert material is what it is, right? Just format everything. Here's my format, my code. So I got my sphere geometry, sphere material, and my sphere mesh. Okay, cool. I want to instantiate a new sphere. Hey, notice that I probably got rid of my plane by accident. That's bad. Let's add that plane back in. I'm going to go var plane is equal to mesh. Got to do that. Sorry, that's my mistake. My plane is first, right? So my renderer, my axis, I'm going to move down here. My plane first, and then on top of my plane, I'm going to add my sphere, right? And I'm going to move my axis helper just for a second. Let's grab this axis helper, cut it, and move it underneath my plane, just from a coding perspective, just to clean up everything the way it looks. Underneath my plane here, under my ground plane, which has a color of whatever that weird color is, we're going to change it to brown. I'm going to add my sphere. So I'm going to say add a sphere to the scene. Sphere is a little different in terms of geometry, right? What do I need for a sphere geometry? Does anyone remember? Do I need X, Y, and Z? What do I need? Radius and? Okay, let's see. Let's check this out. Well, let's start doing it. So I'll say sphere geometry, right, is equal to a new sphere geometry, right? And if I start looking at this, it looks like I need a radius, right? I need width segments as an optional, height segments as an optional. I've got a phi start, phi length, right? I also have a theta start and a theta length, and that's all I need. So I've got a couple options, but the one thing I do need for a sphere is the radius, right? At the very minimum. So let's make the radius of the sphere 5, right? So let's put in number 5. And that suffices, right? Okay, let's do the sphere material. There's a new Lambert material, right? Lambert material, or mesh Lambert is what it's called, right? In the game and the thing. And notice, what do I need? I need at least a color for my Lambert material at the very basics, a color. So my color, I wanted to make it red. So I'm going to go, we use hexadecimal notation here, 0x for the hex, that's what that 0x means, hex. And it's going to be red, I said, right? So R, G, B. Right? There's my color. And now I need my sphere mesh. So I'll say sphere. I'm going to use my object that I've created in I already have an object class. I'll use that. I'll say it's a new game object. And my game object takes a couple of inputs. It needs a geometry first, so that's sphere geometry. And it also needs a material, which is sphere material. And then it also needs an X, Y, and Z coordinate section, because it does all that assigning right from the get-go. Well, I want my sphere to sit on top of my plane. So my X location is 0, but my Y location would be what? If my radius is 5, what should be what's the next thing? 5, right? There we go. And I've got my object. Now I want to add my object to the scene, right? So I'll say scene.add sphere. Right, there we go. So my object gets added to the scene. And I'll make a little console.log, and I'm going to say something like sphere, added sphere to the scene. It's just from a troubleshooting perspective. You can get rid of these later on, just for development purposes. Sphere primitive to the scene. Cool. I got my sphere. I got my plane. I'm doing well. Now here's my axis helper. Instead of my axis helper adding to the scene.add, I want to do sphere.add, right? So I'm going to sphere.add my axis. And instead of my axis helper being only 10, because it's pretty small, let's make it big. Let's make it 20. So that's like how big my axis is going to show. Look really large, right? And I'll save that. It's going to crash for a second, but I'll come back to it. I'm going to go back down to I know where it's going to crash. It's going to crash down here, right? When I do some of my controls. First of all, I don't have an empty object, so that's going to go out of my game loop. So bye-bye empty object. My cube.rotation.y, or whatever, times the rotation speed, it's going to be sphere, right? That's what it's going to be, because I'm going to rotate my sphere. Okay, I'm going to save that, and that should fix my problems, right? There's a couple things I want to get rid of in this thing. I want to get rid of onResize. Let's get rid of that onResize thing. So I'm going to get rid of that function. And as a result, I need to get rid of my window.addEventListener resize on line 110, right? This piece right here. So get rid of that. I don't want to resize my screen in this particular case. All right, cool. All right. Right now, also, I have my config ratio set up for 640 by 480. I want to go back to the other way, and I want to go back and fix that in my config. So I'm going to go to config. I'm going to go to my screen.ts file. Notice that my width is 640 and my height is 480. I want to go back to window width, window.inner width. And I want to go back to this one, window.inner height. So I'll put those back. Here where it says ratio, I want to change this ratio. It's not 1.33 calculated. It's actually width over height, right? Width over height. So width divided by height. Now notice that I'm not getting it, right? How come I'm not getting width over height? How come I can't do that? It cannot find static member width. Well, of course not, because we're defining it here in config. I can go config.width, right? But the problem with that is it's not on my screen. It's actually screen.width, right? Screen.width divided by screen.height. I could do that. Or I can just use window.inner width over window.inner height. I'm only doing this once, so it's okay. Save. I'm going to change my ratio so it's just as big. My whole scene's going to be here. Okay, let's take a look and see what I got here, right? I'm almost done. Whoa. Here's something that you see. Notice how I've got these spines that come out. That's my axis helper, right? My axis helper is like this, and it's pretty darn big. You know what? This is cool and all, but I want to make this a little bit smaller. This is just too big still for me. I'm not happy with this, how big it is. I'm really zoomed in here, right? If I refresh the screen, you can see it doesn't matter. And also my sphere doesn't look like much of a sphere. How come? How can I make this even smoother? I want to ask these questions of you so you can make it so it's more of a smoother sphere. It's red, not really quite red. I want to change my purple to brown. Let's try this out. So I'm going to go back in there and then we'll take a short break. So I'm going to go back to my game as an example, and I want to change my my ground to brown, and I want to add a name to my sphere as well. So I didn't do that. Forgot to do that. So here's my plane. My brown. How do I find a brown color, right? So how do I make a brown color if I don't know, right? If I can Google it, right? Hexadecimal or brown, right? Brown hex value. There we go. Just, going in here. There's one. A5, right? A5 2A 2A. Let's go. Don't take that one. A5 2A 2A. Okay, I'm gonna go back. A5 2A 2A. Put that in here. A5 2A 2A. Save. Let's check that out. We made that change. So we'll check out and see if it's brown. Yeah, it's kind of a brownish color. A little too dark for me, but that's just me, right? Might really want to lighten that up a little bit. And the other thing is the segments. There's not that many segments on this thing. Let's make it so it's more complex, a more complex sphere. Let's try that out. So we'll go back. And if I go to my sphere, let me add my sphere name. Let's say that sphere.name. We'll call this, we'll make it the red planet. The red planet. Just because, what we're doing planets this week, right? So I got my sphere name, and it's red and everything else, but you know what? My sphere geometry is pretty darn simple. I notice how if I hover over it, it gives me some other options. Width segments and height segments. Those are the two other numbers I can put in here. Well, let's put in some width segments and line segments. Let's add in like 32 and 32. Let's make those in there. And press enter. And see what I get now from a sphere perspective. Nice and smooth, yeah? Right? Because that's, otherwise it's pretty jagged and ugly. And you know what? It's still pretty big. Still pretty big here. And my spotlight is, my intensity for my spotlight is pretty, it's way back here. That's where my spotlight is. Oops, that's not what I wanted. So if I look at my spotlight here, right, notice that here's my spotlight color. It's white, right? It's casting shadows. Here's my rotation. I'm rotating my spotlight to where it's supposed to be, right? I've got my spotlight position. And this, I took this off from Blender, if you remember carefully, right? That's where it comes from. But I haven't really set my intensity. And I can set my intensity pretty darn bright. And the way to do that, of course, is go spotlight.intensity is equal to 2. Let's make it double as bright, twice as bright. And now if I go back here, you can see that it's quite bright. Now my spotlight, it's kind of pinging off the top of this thing's head, right? A little bit brighter over here. And you know what? I'm going to change my, this is cool, I like the spotlight, but I want to change my brown. My brown is a little bit too dark. So I want to get light brown hex color, hex value. And I can do that. I can go in here and get a kind of a lighter brown, which is D4CCC5, right from here. So light brown, D4CCC5. There it is. D4CCC5. Save. Once I save, I go back out to here, and now I get a really ugly color. It's not brown. Let's try that again. Did I miss something? I probably did. My fast typing. D4CCC5. How's that brown? That's not the color I want. In fact, it's darn ugly. Right? Let's go back to that. Who told me that D4CC? Do that? D4CCC5. Yeah, that didn't turn out at all. Right? So that's wrong. Don't look at that one. Pale brown, sage green. How about a medium brown? 867970. 867970. Let's try that one. 867970. Let's save that. Thanks, pal. Oh. Okay, I'll take your suggestion. So what is it? Uh-huh. 60. Okay, let's see what you got. See if this is a real brown, if you're right. Yeah, I like that brown. That's a good brown. I want to make this sphere smaller, right? So I want to make it like half the size. Let's make it like 2.5. Can I do that? Can I make it 2.5? Let's try it out. So I'm going to go back down to here, and in my sphere geometry, instead of 5, I want to make it 2.5. So half the size, which means I'm also going to move the sphere 2.5 up from the ground. Right, there we go. And my sphere receives shadows. Does my sphere cast shadows, right? And if for you guys to know that, let me go back to this. Is there any shadows in the ground? How come there's no shadows on the ground? I receive shadows, but I don't see any casting of shadows on the ground. Does my ground receive shadows? It does, right? I've got this, thing going on where I got a spotlight that's coming. I should see a shadow down here, no? Right? So how come I'm not seeing a shadow? Let's go back to my my configuration here and check it out. So I'm going to go to Objects. I'm going to go back to my Game Object. Well, here's my Receive Shadow. Here's my Cast Shadow. So if I've got my plane, how come it's not working? How come my Cast Shadow, even though I say Cast Shadow is true, how come my geometry is not meeting up with my shadows? Anyone seeing shadows that I don't see? What do I need to do with the camera? Let's check this out. So let's go back to, well, let's go back. So what do you recommend if I was going to go back to, because this is all the stuff that you guys have problems with, right? Tom, I can't see my shadows. My shadows have real problems. And how well, let's check this out and fix it for me, right? So what do I do? So here's my camera. Are you saying that my camera, I got to enable shadows on my camera? How do I do that? So here, camera.shadow map enabled. Well, cast shadows says camera. Well, cast shadow for my camera, but that's not it. How about my scene? Is that what you mean? You mean my scene's got a well, or here's my renderer. My shadow map enabled is true on my renderer. That's already there. Yeah, my camera can cast shadows too, but that's kind of weird because it's just a 3JS object, right? So it's casting shadows, but I'm not seeing any shadows. How come? I got ambient light. What if I turn that ambient light off for a second? Right, so let's turn this off. So kind of in this ambient light to show you where this happens. I don't need to do anything else. Save. There's my ambient light. How come I'm seeing no shadows on this funky material over here? How come? How come? Okay. Well, my camera is good. My camera can see everything, right? But what about my spotlight? What's the other value that my spotlight has? My spotlight has an intensity. It casts shadows, right? What other thing can my spotlight do? Let's take a look. Spotlight. It does a couple things. Angle, so I can see how wide my spotlight is, right? I can determine, I haven't talked about my angle here at all for my spotlight. Let's make it an angle of 60. Remember, what angle is this, right? How do I change from degrees to radians? Because everything's in radians, right? What's radians? Pi divided by 180, right? So I'm going to say 60 multiplied by pi, math.pi divided by 180, and I want to put this in brackets, yeah? That's 60 degrees. All right, let me just save this thing so you see what's happening with my spotlight. My spotlight just opened up a little bit more. I went 60 degrees now. That's one thing. What else can I do with my spotlight? This is the spotlights, right? So spotlight dot, let's see what else I can do. Channels, children, clone, color, blah, blah, distance. Whoa, there's distance. Okay, so distance, if I hover over what that is, right, it says if non-zero, light will attenuate linearly from maximum intensity at light position down to 0 at the distance. The default is 0.0. So I want to make my distance a great distance. Because remember, I put my spotlight, my rotation is so far, but look at my distance, like 23, it's pretty far away, 23, right? So let's make my distance when it attenuates down to 0, 50. Kind of long, right? So it won't attenuate. All right, now, here's something. My scene just got darker, right? My spotlight attenuates at 50 units. Okay, let's change that to 100. Attenuate means goes down to 0, right? Here's 100. Take a look how it's just brighter now. Let's go to 200. Right? No difference, and still no shadows going on with the sphere. I got the shadow here, but I got nothing. Any other ideas? Take a look at this. Look at the axis helper. As I'm rotating, right, so too does the axis rotate. Think about this axis as an invisible plane that's just sitting there like this, rotating around the scene. That's what's happening. With this is your sun, and you know objects are rotating around it. Think about this as this invisible plane. Everything else is rotating around it. So as my sphere rotates, so too does its axis, which messes you up, right? Because that means that the axis also changes. The axis positioning, what it's looking at, what's the sphere looking at? Right now, we don't think about an object looking at anything. but the sphere actually has a look at, right? My camera, I can use look at to look at a particular point inside the camera itself. Let me take a look at that. If I go to my camera, I have a camera look at. Well, look at doesn't belong just to the camera. My look at also belongs to all objects reviewed, right? So notice that in the beginning, my camera is looking at the 0, 0, 0 point. That's what it's looking at right now, okay? The 0, 0, 0 point. How come there's no, I don't understand. How come there's no shadowing on the plane, man? I don't get it. Should be seeing all kinds of shadowing here. Any ideas? Take my file. Here's the thing I want you to do at the break. Take my file. I'm gonna upload it to GitHub now and upload the changes, right? And I want you to make the ground have a shadow, right? Fix it. Right, so I'm gonna go to GitHub. I'm gonna add all this stuff in, and then removed sphere, or remove cubes, added and added sphere. Push. Guys, this is a very good thing to do. If I gave you something that's broken on your exam, I said, it's broken, fix it, right? It's one of the hardest things to do if you're ever given that kind of question, because I'm giving you a piece of code that's not your own, you're gonna fix, right? It's way harder than you doing your own code. Let's take a short break. When we come back, hopefully someone will give me the fix, and then we'll start talking about some movement with the camera.